Okay, so let's say we've got a plane here, and I'll delete its history, freeze its transformations. And we can, another way of creating particles is to emit from an object. And so this is quite useful too. So this can be useful if you want to make sort of particles rain down from not just an omni emitter. You could use a volume emitter for this, but if you want them all to start in the same place, you could use a plane like this. So this plane now, if we open the options, so the emitter type instead of omni, now we can change it to surface. You can see they can also emit from curves as well. And you'll want to turn this on, and we'll talk about why in a minute. It's called need parent UVs. And it says NURBS, but it works for polygons too. So parent UV, so UV means the surface coordinates of this object. So this is a simple thing, and it's got its UVs built in. So it's going to have a U direction and a V direction. And so if a point here in the middle is 0.5, comma 0.5 in U and V. So it tells us where it is, surface address. And when you turn on need parent UV, it just records the position where each particle is born. And that can be useful information. So we want to turn that on. So I'm going to turn off speed, so I'll just have gravity pull them down. Press create. So now if we play the animation, gravity should just grab them and they fall down. So if you want them sort of particles raining down from something above equally, then this is a good way to do it. So if we want these particles to stick to this surface, so I'm just going to change their size a little bit. If we want particles, oops, don't do that. If we want particles to stick to something, you have to make a goal between them. So you have to set this plane as a goal for the particles. So if I select the particles and shift select the plane, we can go to nParticles, and up here there's a goal option. We can turn that on. So by default, I think the goal weight is set to 0.5, but we want to set that to 1. So it listens to that 100%. So I'll create that. And now if I rewind the animation, we'll see something not nice looking, but it... So, I mean, Adam, even for you, I was thinking about, you're growing those things. You could look at something like this as a way to have particles be born in a certain order over the surface. You see it gets wonky because they have self-collide turned on, and they're being born, and they're locked to the exact same vertex. So they're fighting with each other. But it's also, what's happening is that they are being locked to each vertex. So if we select the particle and turn off self-collide, we can see that a little more clearly. So now they're not colliding with each other, they're just being born, and new ones are being born along the surface. But they're actually not being born at those vertices. They're being born at a random spot on the surface at a UV address and then leaping to the next vertex in the order. But we want it to stick to the place where they're born. So here comes a little expression writing. And also, we don't want this many of them, so let's reduce the count to something different. So emission attributes in the particle node, we'll just change it to 100. Nope, not 0. To 100. So now if we play, yeah, so it doesn't even quite fill it up. So let's write a little expression here. If we just go down to, yeah? So when you select the particle and then shift select a piece of geometry, and I'm not going to do it again because I already have a goal, but if you go to nParticles and goal, then it's going to goal weight. So it's going to make that plane a goal object. So they'll try and get to that object. for the particles.
Oh yeah, but how does it know to go to the vertex?
So in any piece of geometry, the primary component is the vertex. And from the vertex, the edges are formed, and from the edges, the faces are formed. And so when you don't give it any other information, when you give something a goal to a piece of geometry, it's going to look to that primary thing. So it knows to go to the vertices. That's just the default state. So, but we're going to change that. So you can see that when we created this goal, or this particle born from the surface, we told Maya to record the parent V and parent U. So the point on the surface where it was initially born. But we want to add some new per particle attributes. So right under here, this is the per particle array attributes section. And right under here, we can add dynamic attributes ourselves. So you can see the default ones, RGB PP, lifespan PP, and then there's goal PP. So because we set a goal, there's a goal per particle. So this is how Maya knows to put this particle 16 on vertex 16 or whatever. But we wanted to change that a little bit. So we're going to add dynamic attributes. If you click here under particle, there's a bunch of preset ones. There's tons of stuff. You don't have to worry about it too much. You can see there's parent U and parent V, so recording its birthplace. But we want to add goal U and goal V. So Maya knows that there's a goal, and it doesn't know where to put it exactly, so it's putting it on the vertices, but we're going to tell it where to put each one. So we'll just select goal U and goal V and say OK. So now we'll create a very simple expression. So when you want to create an expression here in the per particle attribute array attributes, you don't just you can't double click and type into these fields, although it looks like you should be able to. You have to right click in this field beside the name and tell it what kind of expression you want to create. And we're going to mostly be looking at these three: creation expression, runtime expression, before or after dynamics. So creation expression. So this is something that only gets run once when each particle is born. It executes this command. So we're just going to say that the goal U of the particle, so where it sticks to the surface, should be equal to its parent U, the place that it was born. End it with a semicolon. Same thing, goal V equals parent V. And we'll click create. So whenever you write an expression, once you end a command, always have to end in a semicolon. You click create down here to finish it, and then once there's already an expression in here, if you make a change, then you have to click on edit afterwards. This, by the way, is all recorded on the BMC Wiki and the particles under Maya. You go to particles. It's old stuff, and it's not applying to nParticles, but it still works. So now if we replay, now they're just born and stick where they're born. And now if we do something like, I'll just put a deformer on here, nonlinear. Let's do a sine wave. So this is not on the particles, but on the plane. So you can see they're not sticking right now, and they won't until we advance the timeline, because it has to reevaluate. So now if we just write an expression in the offset value, just say, this is of the sine wave, just say offset equals time. So now they can be born on the surface and stick there. So this is another way you can do a lipid bilayer and use particles for the lipid heads, but the problem is it gets very difficult to move them around in a natural sort of fashion. You can write expressions that say on each frame, move in a random direction, like a certain distance in UV, because this all depends on UV. But it's much easier to do that box. I know it didn't work that well when I was showing, but to make a box and lock them inside of it, because then you can just shift them around using fields and things like that rather than expressions. Okay. Any questions so far? Yeah.
Sorry, I can't get the goal to work. Is there something else that you did before you set the goal?
I made the particles. They emitted from the object.
Yep.
Selected the particle, shift selected the object, and then did goal to 1.
That was working, okay.
Yeah. I just had to say the magic words.
Yes.
Okay. So let's just got 15 minutes before we break, and I'm just going to show you quickly how to instance geometry to particles. Now, it sounds like some of you have done this already. But we'll talk about a few things. So, and we're going to do more elaborate instancing after lunch when we do blood flow. So just to make this easy to see, I'm going to create something that has direction. So I'll create a polygon cone. So now if we look here, the polygon cone is pointing in the y-axis, right? So the apex of the cone is going in the y direction. So I'll just delete this thing's history, freeze its transformations. And I'm going to replace each of these particles with this object. So that's called object instancing or particle instancing. So with the object we want selected, just the object, we can go to nParticles and go to instancer up here and open that up. And because I had it selected, it recognizes that as a selected object. I can add more to that. I can add later on. And the particle to which the object is instances is called the nParticle shape. No, it's the only one in my scene, so it's the only one to choose. But if I had more than one shape node, I could choose amongst those. I can just leave all this stuff as is. Now I can click Create, and you can see. Now you can see them down here, but the particles are blocking them. So I'm going to select that particle and just hide them. So I can do that by making it an intermediate object myself. And let's change the color of this thing so it's easier to see. See if it works with Mila. It should. Yeah. So now we can play the animation. So you can see they're not moving. They're moving with it, but they're always pointing up right now. So if we want to change the way they're oriented on the surface, let's see if I can remember how to do this. We can select those particles and change some of their settings. So if we look, let me just close some of these so it's a little easier to see. Okay, so this is in the particle node. There's a control built in here that has no relevance unless you instance geometry to the particle, and then we can look at this and see what it's doing. So right now the instancer node is that cone inst that I created, and right now it's got an aim direction of none. So it's just aiming the direction that it was born at, which is pointing up. So if I change this, now let's see if I can remember. So we can change things like acceleration, and this will change how they're pointing depending on how they're moving. So you can see as the wave propagates through there, they flip around. I'm going to open up the Wiki just so make sure I'm doing this right. So if we go here under software applications to Maya, there are some old tutorials in here. So surface emitted sticky particles. So this gives you all the kind of instructions that we're talking about here with the goal U, goal V. This is with the old particles, but it works just the same way. So here's kind of what we're doing now. So we've done the instancer. So in order to make the cones point away from the surface, you have to add a new per particle attribute. And this is something called goal point normals. So you know that a surface has normals pointing out of it that indicates how light is going to bounce off the surface. So we can use that normal direction to orient our particles. So we can find that here under goal weights. Oops. No, maybe not. Goal weights. No, cannot find object 2. I think I have to turn off that intermediate object setting for this to work. Okay, so let's see if this is going to work. Okay. So there's a whole bunch of different things you can do here. You can change goal point positions using this in a way it's similar to what we did earlier. But we can also turn on goal point normals. So we create that. It's giving me a warning, so I don't know if it's going to work. It seems to have worked. I want to get rid of these spheres without turning it into an intermediate object, so I can just go to shading, and instead of blobby surfaces, I'll just change them to points so we don't see them. So now what this is doing, Maya is recording the normal at the point where the goal weight is. And we can use that to drive the aim direction, or the up axis. Let's just see. So for aim direction, we can select goal world normal 0 pp. So aim direction. Yeah, it's giving me a weird warning. Let me try that again, sorry. Yeah, this should pop immediately to the direction, so there's something weird going on here. Oh. Should be in direction. It's changing, but not in the way that we want. Okay, so it did change. But you'll see that they're lying on their side. And there's no reason for Maya to know that we want the pointy side to stick out. It's because Maya automatically uses the x-axis is the direction that it points out. So if we just rotate this thing, our original thing, and then I think if we just freeze its transformations, yeah, they'll all pop to that direction. So you just have to make sure it's oriented along the x-axis the way you want to point out, and then it will do what you want to do. So this is great for, let's say you create HIV or something and you needed those regularly surface proteins. In that case, you might want to put them on the vertices of something. If you wanted something placed randomly along the surface, doing this goal weight in this way works well, using the goal point normals to make them point outward. But getting them to move around the surface is a whole other challenge. We'll talk about that later, writing an expression that can do that. You can see, I mean, we've done a bunch of things already. We've created floaty particles, we have instance geometry, we've generated new geometry from particles, we've stuck particles to surfaces. I don't think there's any project I've ever done that I haven't used particles in some way. And most of your projects will have something in them. But in all this biomedical type of animation, particle solutions always come up. You can't avoid it. So there's particles, and then later on we will talk about XGen, which is not a dynamic solution really, but it's a way to, like this, distribute objects over a surface, which will be useful for a lot of people too. Any questions? You want me to go over? No. So what we're going to do after we have a break for lunch is that I'm going to demonstrate the blood flow technique for getting blood flow particles going down a tube. And then I'm going to get you guys to recreate that as well, work on that for the rest of the afternoon. That shouldn't be too hard. And then if there's anything you want me to look at specific with particles, I can try. Okay? Great. So it is now about 12:30, so we'll start again at 1:30 and I'll do that final demo. Thank you.